Hello, so this is a revision video for IB Chemistry S2.2.7, Covalent Network Structures and Allotropes. Some nonmetal elements and compounds form giant covalent network structures. These have no maximum size and all atoms are covalently bonded in a repeating pattern. Common examples include diamond, graphite, and silicon dioxide. Allotropes are different structural forms of the same element, where atoms are bonded in different arrangements. Because of this, allotropes have unique chemical and physical properties such as hardness, conductivity, color, or reactivity. For example, carbon exists as diamond, which is hard and transparent, and graphite, which is soft and conductive. In diamond, each carbon atom bonds to 4 others in a 3D tetrahedral lattice, with no maximum size. Carbon atoms can keep bonding to more carbon atoms in a repeating tetrahedral pattern. As a result, diamond has a very high melting point of over 3,500 degrees Celsius. This is because to melt diamond, you need to break lots of strong covalent bonds, which requires large amounts of energy. Diamond is unable to conduct electricity because it doesn't contain any free mobile electrons or ions, and it's incredibly hard due to the strong covalent bonding extending in all directions. In graphite, however, each carbon atom only covalently bonds to 3 other carbon atoms, forming hexagonal layers. There are delocalized electrons between these layers, and weak forces of attraction hold the layers together. Like diamond, graphite also has a high melting point because to melt graphite you need to break lots of strong covalent bonds between carbon atoms. However, unlike diamond, graphite is able to conduct electricity because the delocalized electrons between the layers of carbon atoms are able to move freely. The weak forces of attraction between the layers make graphite soft and a good lubricant, because the layers can slide over each other easily due to the weak forces of attraction only requiring low amounts of energy to overcome. Fullerenes are another allotrope of carbon, where carbon atoms are bonded together to form molecules with spherical shapes or tubes, like buckyballs and nanotubes. Fullerenes are molecular substances, so substances made up of molecules, rather than the giant network covalent substances like diamond and graphite. As a result, they are generally soft and have low melting points compared to diamond and graphite, and are poor conductors of electricity. Graphene is another allotrope of carbon that exists as a single layer of graphite. It is 1 atom thick, with each carbon atom covalently bonded to 3 other carbon atoms, with delocalized electrons. As a result, for its size, it's extremely strong and flexible, and an excellent conductor of electricity due to the delocalized electrons being free to move. Silicon also exists as a solid at room temperature, and like the carbon in diamond, each silicon atom forms 4 covalent bonds in a tetrahedral structure, forming a giant covalent network. It's very hard, has a high melting point, and is a semiconductor, so it has limited conductivity in normal state. Silicon dioxide, SiO2, has a similar structure to diamond, but here each silicon atom is covalently bonded to 4 oxygen atoms, and each oxygen atom is further bonded to 2 silicon atoms, meaning it has a giant network structure and is hard, insoluble, and has a high melting point. It is unable to conduct electricity as it contains no delocalized electrons or ions that are free to move.